Welcome to Medical English Edge, B2 to C1 for Pharma Pros. I'm your host, and today we are diving into a critical topic for anyone in the pharmaceutical and medical field: understanding early COPD, how to predict disease progression. We've structured this session specifically for professional growth. We'll start by reviewing a recent systematic review from PubMed, rewritten for B2 learners. Then, we'll level up to C1 vocabulary to sharpen your professional discourse, and finally, we'll transition into a deep dive discussion. Quick reminder, this content is for educational purposes and does not constitute medical advice. 1. Research overview, CEPHR B2 level. Why is it so difficult to define early lung disease? Chronic Obstructive Pulmonary Disease, or COPD, is a serious condition. While doctors aim to identify it early to improve patient outcomes, this study highlights a significant hurdle. There is no global agreement on what early COPD actually means. After reviewing over 4,000 research papers, the authors found a staggering variety of terms, such as pre-COPD or at-risk COPD. This lack of a standard definition makes international collaboration nearly impossible. The study also identified key predictors that suggest the disease is progressing, including age and smoking history, physical symptoms like persistent coughing or dyspnea, clinical data from lung function tests and CT scans. The takeaway is clear. Achieving a single, shared definition is a prerequisite for starting treatments sooner and potentially halting disease progression. 2. Level up, C1 vocabulary for experts. To participate in high-level medical debates, you need precise language. Let's look at the key terms used in this study. Consensus, a general agreement. In your meetings, this refers to the official collective opinion reached after long deliberation. Fragmentation. This describes the current state of medical terms, scattered and inconsistent across different regions. Heterogeneity, a sophisticated way to describe the wide variety of symptoms or biological causes found in the same disease. Necessitate, instead of saying make it necessary, use this formal verb to describe consequences. For example, the lack of data necessitates further research. Reductive, use this critically when a complex problem is presented in a form that is too simple, causing important details to be lost. 3. Transition to discussion. Now that we've laid the groundwork with the research highlights and advanced vocabulary, it's time to see these concepts in action. Up next, we have an automated deep dive discussion generated by Notebook LM. Listen closely to how these experts navigate the complexities of COPD definitions and disease predictors.
All right, today we are going to level up your communication skills. Seriously? We're talking about moving beyond just being understood and into the realm of being genuinely influential. If you've ever been in a conversation searching for that perfect word to make your point with total precision, well, you are in exactly the right place.
So are you ready to make that jump? This is all about swapping out everyday language for a more expert vocabulary. We're going to dive into a handful of C1 level words that will give you so much more clarity and confidence, especially when you're talking about complex ideas.
First up, let's talk about words that help you describe the big picture. You know, how large, complicated systems are supposed to work, or, as is often the case, how they tend to break down. This is the kind of vocabulary that's absolutely essential for any serious discussion, whether it's in business, science, or policy.
Okay, so our first word is fragmentation. This is what happens when a system is just broken into all these disconnected pieces. Think about it in healthcare, for example. You might hear about the fragmentation of medical records. That's where different hospitals use totally incompatible systems, and getting a single complete patient history becomes almost impossible. It's the perfect word for a lack of cohesion.
And you know that kind of fragmentation? It often creates what we call a silo. A silo is basically a system or department that's operating in total isolation from everything else around it. Just picture a big company where the marketing team and the product development team never, ever talk to each other. They're working in separate silos, and it absolutely kills collaboration. A classic example you'll hear is research silos, where scientific teams don't share their data and progress just stalls.
Now, within these complex systems, we almost always find heterogeneity. It's a great word that just means diversity or variety. In medicine, it's a really critical concept. A disease with high heterogeneity means that two patients, both with the exact same diagnosis, could have wildly different symptoms. It's the perfect word to use when you need to say, look, this is complicated because it varies so much.
Okay, let's switch gears a little and talk about the language of inquiry. These are the kinds of words that really build your credibility, especially in scientific or academic conversations where evidence and precision, well, they're everything.
And that brings us to a huge one, empirically. When you verify something empirically, it means you have proven it with real-world observable data, not just on a whiteboard with a theory. Being able to say that a claim has been empirically verified, honestly, that's one of the most powerful things you can say in any evidence-based argument. It means you've got the receipts.
All right, here's a word that might sound a little more specialized, but it's incredibly useful: phenotype. This is the scientific term for the observable traits of an organism. Things like your eye color, your height, things you can actually see and measure. It's different from your genotype, which is your underlying genetic code. It's the perfect word for making that clear distinction between what we can see and what's written in the DNA.
Ugh, I love this one. Here is a powerful, powerful upgrade. Instead of saying an argument is just oversimplified, you can critique it as being reductive. Calling an analysis reductive is such a sharp, intelligent way to point out that it's completely ignoring essential complexity and nuance. It's a real mic drop kind of critique.
In our third section, let's really focus on the vocabulary for building a rock-solid case. I mean, whether you're in a debate, a work meeting, or even just writing an important email, these words are going to add so much weight and precision to your arguments.
Okay, let's take a common phrase that we all use all the time: essential condition. It's fine, it works, but we can do better. There is a single word that just elevates this whole idea instantly. And that word is prerequisite. A prerequisite is something that absolutely must happen before something else can even be possible. So saying basic coding knowledge is a prerequisite for this course is so much more formal and concise than saying it's an essential condition.
And here's another fantastic level up. Instead of that kind of clunky phrase, make it necessary, you can use the powerful verb necessitate. The new data will necessitate a change in our strategy. See, it's direct, it's formal, and it communicates that cause and effect relationship with real authority.
Let's just round out this section with 3 more mighty tools for your toolkit. When you want to show that a group has reached a general agreement, you use consensus. To acknowledge that there's a huge variety of opinions on the table, you can talk about a plurality of views. And when you need to hammer home your single most important point, you call it paramount. For example, client safety is of paramount importance. It leaves no room for doubt.
And for our final section, let's go big. Let's look at words that convey huge scale and massive impact. Because when the results of something are enormous, you need adjectives that can really carry that weight. These words add drama and emphasis right where you need it most.
So imagine you're presenting some findings from a study. You could just say 9 out of 10 participants agreed. I mean, that's a fact. It's accurate. But how do you convey the shock of that fact? How do you make your audience really feel its weight?
You say the findings were staggering. See, that one single word transforms a dry statistic into a powerful, almost emotional statement. It tells your audience that this result isn't just high, it's absolutely astonishing.
And that's the power of the word staggering. It means deeply shocking or astonishing. You should use it for overwhelming numbers, unbelievable discoveries, or any result that just completely stops you in your tracks. It's an adjective that truly delivers an impact.
But what about when something is so dense and complex that it's just impossible to understand? This quote here captures it perfectly. The word is impenetrable. It doesn't just mean it's difficult, it means it's like a solid wall you just can't get through. An impenetrable report, an impenetrable legal document. It describes a total and complete lack of accessibility. So let's do a quick review of your new C1 toolkit. Instead of essential condition, you're going to use the more precise prerequisite. Instead of just saying isolated teams, you can talk about teams working in silos. You're going to ground your strongest arguments empirically. And when the results are truly massive, don't be afraid to call them staggering. And that brings us to the end. You know, the real power of these words isn't just in knowing them, it's in actually using them. So my final question for you is pretty simple. Which of these new words will you use first? Thanks for joining me for this explainer.
Welcome to the debate. Imagine for a second knowing a massive storm is brewing right off the coast, threatening to destroy your entire town. But instead of sounding the alarm and boarding up the windows, the local meteorologists are locked in a room somewhere.
Right, arguing with each other.
Exactly. They are arguing over whether to officially classify it as a cyclone, a hurricane, or a severe typhoon. And because they cannot agree on the name, no official warning actually goes out. That paralyzing lack of consensus is Well, it is exactly what is happening right now in respiratory medicine.
I mean, it is a striking image. But I would argue it is not that they cannot agree on the name. It is that they are tracking fundamentally different types of weather systems. And pretending they're all the exact same storm would be the real disaster.
And that fundamental disagreement is exactly why we are here today. We are diving into a highly consequential, systematic review by Watson and colleagues. It was published recently in the European Respiratory Review.
Yeah, and it is a massive undertaking.
Oh, monumental. This research team took on the task of screening thousands of clinical studies focused on what we generally call early COPD, Chronic Obstructive Pulmonary Disease. This is that crucial transitional phase of lung disease before permanent, irreversible damage sets in. They wanted to analyze the terminology being used and the tools we use to predict how this disease actually progresses.
And what they uncovered is a diagnostic landscape that is just entirely fragmented. I mean, the waters are incredibly muddy here.
They really are. Which brings us to the central tension of our discussion today. Based on the Watson Review, we have to ask, does this current fragmentation of early COPD terminology necessitate an urgent unified consensus definition so we can actually advance clinical care?
Or does this plurality of terms accurately reflect distinct medically necessary clinical phenotypes, meaning different physical realities in the patient that a single definition would dangerously obscure?
It is a pivotal question, because how we define the very beginning of a disease, well, it dictates every single step we take to try and cure or halt it.
Absolutely.
So, my position today is that the current lack of a standardized definition is a critical, almost existential barrier to respiratory research. Establishing a single unified consensus on what constitutes early COPD is the essential prerequisite for everything else.
I see.
Without it, we cannot validate our predictive tools, we cannot pool data across global populations, and ultimately we cannot improve patient outcomes. We are entirely stalled by our own vocabulary.
Well, I will be taking the opposing view today. I believe the sheer heterogeneity of this terminology is a feature, not a bug. It reflects the deeply complex, multi-pathway nature of how lung disease actually begins. Enforcing a reductive consensus definition just to make, administrative guidelines or research databases look neater, it risks discarding vital granular data.
But that data has to be usable.
And it is usable. That granular data is absolutely necessary if we ever want to achieve true targeted management for individual patients.
Well, let's look right at the scale of this fragmentation, because the Watson Review explicitly demonstrates a crisis here. In stage 1 of their review, the authors screened over 1,700 articles, and what they found regarding terminology is staggering. Proposed definitions for early COPD are simply not routinely used. Instead, researchers are operating in totally different linguistic universes. They found the term PRISM used in 104 articles. They found gold zero used in 63 articles.
Right.
Then you have early COPD in 37 articles, at-risk COPD in 35, and pre-COPD in 30. We have respiratory experts across the globe looking at the exact same transitional phase of lung disease, and they are using 5 distinct primary terms to describe it.
Right, but
Our ability to fight the disease. If an investigator in Tokyo is running a massive study on pre-COPD and a team in London is studying gold zero, pooling their data to figure out what actually drives disease progression becomes a statistical nightmare. We cannot fight a global disease if we cannot even agree on its name.
I come at it from a different way. You look at that list of 5 terms and see a crisis of communication. I look at that exact same list and see necessary scientific precision.
Precision?
Yes, precision. The diversity of those terms is empirically justified by the research itself. Let's look at stage 2 of the Watson Review. They evaluated 43 full-text cohort studies to look at predictors of progression. When they appraised the quality of these studies, an overwhelming 93% of them were rated as good quality using a modified Downs and Black checklist.
Sure, the individual studies are good, but
Think about that, though. If the lack of a singular definition was truly paralyzing the field, as you suggest, these rigorous, high-quality studies wouldn't exist. They would be fundamentally flawed from the start, but they aren't.
But they are operating in silos. That is the problem.
They are operating with precision. Terms like PRISM, and gold zero aren't just fancy synonyms for early COPD. They capture highly specific physiological states. Let's break that down so we aren't just throwing acronyms around.
Please do.
Take PRISM, which stands for Preserved Ratio Impaired Spirometry. Spirometry is basically just a test where a patient blows into a tube to measure how much air their lungs can hold and how fast they can blow it out.
Right, the standard lung function test.
Exactly. So a patient with PRSM is like a balloon that has shrunk. Their total lung capacity is smaller, but the speed at which they can deflate that smaller balloon is normal. The ratio is preserved.
Right, their lungs are proportionally smaller, but the mechanics of the exhale are structurally intact.
Exactly. Now compare that to gold zero. A patient classified as gold zero has a totally normal balloon. Their spirometry tests are perfectly healthy, but they have chronic symptoms like a persistent hacking cough or heavy mucus production. You cannot tell me that the shrunken balloon and the normal balloon with a cough are the same physiological starting line.
What?
They are fundamentally different biological realities. A blanket early COPD definition would completely erase that critical distinction.
I see why you think that, but let me give you a different perspective. Yes, PRISM and GOLD do describe different physiological measurements. I am not denying the biology here, but by allowing 5 distinct primary terms to arbitrarily govern the research landscape, we are creating impenetrable research silos.
I just don't see them as impenetrable.
It is akin to trying to build a global early warning system for earthquakes, but the regional scientists cannot agree on the fundamental definition of an earthquake. The scientists in California say an earthquake is defined strictly by the underground seismic shifts, the tectonic plates moving.
Okay.
But the scientists in Japan say, no, an earthquake is defined by the resulting structural damage on the surface, the cracked foundations.
I see where you are going with this.
Right, so some scientists are only measuring the plates. Others are only counting the cracks. Without a unified metric consensus on what constitutes the actual baseline event of an earthquake, that global warning system can never be validated.
But
We have 104 articles on PR or SM and 63 on gold zero. But how many potential clinical breakthroughs are lost because these datasets cannot be seamlessly integrated? The Watson Review explicitly states that this lack of standardized definitions hinders clinical application. If the research cannot transition from the academic journal into the clinic because the terminology is completely fragmented, then the precision you are defending is essentially entirely theoretical. I reject the earthquake analogy because I think it fundamentally misrepresents what these respiratory researchers are actually measuring. PRISM and gold zero are not conflicting definitions of the exact same phenomenon, like tectonic shifts versus cracked concrete. They are entirely distinct parameters.
How so?
It is much more like trying to understand the weather. You are arguing that we should stop differentiating between temperature and humidity because keeping track of both makes the global database too complicated.
Wait, I am not saying we ignore the data. I am saying we need a unified categorization.
But categorization dictates the data we value. If you want to understand the climate of the lung before a formal COPD diagnosis, you need to measure the temperature and the humidity separately. You need PRISM and you need gold zero because they represent entirely different mechanisms of lung vulnerability.
I hear you, but
if we force a consensus definition, say we just broadly define early COPD as anyone with a slight drop in forced expiratory volume, the amount of air they can push out in 1 second, we are suddenly averaging the temperature and the humidity into a single meaningless number.
So you were saying by averaging the weather to make the data cleaner, we miss the tornado entirely?
Exactly. You would look at a weather score of 50 and not know if the patient is freezing or standing in a monsoon. The 93% of good quality cohort studies identified in the Watson Review achieved their high quality precisely because they rigorously defined their specific parameters, not because they blurred them together for the sake of a simplified global registry.
Okay, but knowing the name of the disease, or the specific weather pattern to use your analogy, it doesn't matter if we cannot predict where it is going. And that is where this terminology crisis spills over into actual patient prognosis. Let's look at the actual validation of predictors, which is the second major focus of the Watson Review. The debate naturally moves from the terms we use to describe the state of the lung to the specific tools we use to predict how fast that lung will fail.
Right. Predicting the trajectory of the disease.
Exactly. The review identified several categories of predictors being used across these studies. Age was used as a predictor in 13 articles, smoking history in 12, and patient symptoms in 12. But here is the fundamental flaw. A predictor is only as valid as the outcome it is attempting to forecast.
Sure.
If the endpoint, the definition of what disease progression actually means, is vaguely or variably defined across these studies, then the predictive value just collapses.
How so?
Because the finish line is constantly moving. For instance, the review notes that an exacerbation, a sudden, severe flare-up of breathing issues, was used as a predictor for progression in only one article. Establishing a causal or predictive link to a flare-up lacks any clinical rigor if we do not even have a consensus on what threshold crosses a patient from early disease into established COPD.
Well, but
If Study A defines progression as a 10% drop in lung capacity and Study B defines progression as simply the onset of a chronic cough, how on earth do we validate age or smoking history as reliable predictors? The outcome variables are entirely different.
I'm sorry, but I just don't buy that. Let me tell you why. You're focusing on the more generalized, subjective predictors, like age, smoking, and self-reported symptoms. But look at the highly specific, data-heavy predictors identified in the Watson text.
I mean, they still fall victim to the same issue.
No, they don't. Lung function measures were utilized across 20 articles. Computed tomography, CT scans, were used across 14 articles. These are incredibly objective, mathematically sound predictors.
But they still need an outcome to predict. You can have the best CT scan in the world, but if you don't know what constitutes the disease state it's predicting, what good is it?
Yes, but they measure structural reality, not semantic thresholds. A CT scan measuring the exact millimeter thickness of an airway wall, or calculating the precise percentage of emphysema in the lung tissue, doesn't care about our semantic disagreements over what to call the disease.
Okay, fair point on the structural reality.
Furthermore, the review highlights the emergence of machine learning approaches in 3 articles and specific risk prediction tools in another 3. This is where the field is heading, and machine learning algorithms actually thrive on diverse, highly granular data points.
They still need clean data.
They need complex data. They want the distinct CT metrics. They want the specific PRISM classifications. They do not want reductive, human-engineered consensus definitions. When you feed a neural network high-dimensional data like, thousands of pixels from a CT scan alongside a patient's exact spirometry ratios, it finds hidden predictive pathways that human researchers simply cannot see.
Right, but
If we simplify our definitions to create a neat, tidy early COPD box, we are actually depriving these advanced predictive models of the nuanced variables they need to map out the true trajectory of the lung's decline.
I do not disagree that CT metrics and machine learning offer incredible transformative potential. We are totally aligned there. But you are ignoring a fundamental rule of artificial intelligence. The models still require a labeled outcome to train against.
What?
You are training a machine learning model to predict disease progression, but your training data contains 50 different clinical interpretations of what progression actually is. The algorithm is just going to output noise. It is garbage in, garbage out.
It is not garbage. It is physiological variance.
But it brings us to the ultimate goal highlighted by the source material, which is targeted management and patient outcomes. The entire mechanics of academic research and machine learning prediction are completely useless if they do not lead to halting or modifying the disease in actual human beings.
Of course.
The Watson Review reaches a very definitive conclusion on this. They state unequivocally there is an urgent need for consensus on clinically applicable definitions of the early disease course prior to diagnosis.
For the sake of clinical trials, maybe.
No, for the sake of the healthcare system. Think about the primary care physician, the family doctor. Without standardizing what early COPD is, how can a clinic logically implement targeted management?
But targeted management means
A general practitioner does not have a high-res CT scanner and a supercomputer running neural networks in their back office. They need a unified set of guidelines that clearly defines the early disease state so they know when to intervene. We cannot build public health protocols insurance reimbursement frameworks, or widespread clinical intervention trials around an abstract plurality of terms. Standardization is the vital bridge between theoretical research and actual patient care.
That's a compelling argument. But have you considered what targeted management actually means in the real world of modern precision medicine?
I mean, treating the patient effectively.
Right, but true targeted management requires stratifying individuals based on their exact physiological reality, not forcing them into an administrative consensus category just to make an insurance claim easier to file. Let's actually ground this in the clinic, like you suggested. Let's construct a scenario based strictly on the review's findings.
All right, let's hear it.
You have patient A. Their early disease is characterized by structural emphysema. We can see it perfectly using those CT metrics found in the 14 articles. What that means biologically is that the tiny air sacs in their lungs, the alveoli, are undergoing parenchymal destruction.
They are breaking down.
Exactly. They are losing their stretch, breaking down into big floppy bags that trap air. Now you have patient B. Their early disease is identified solely by PRSM. Their air sacs are fine, but their airways are structurally narrowed, perhaps due to chronic inflammation.
Okay, two distinct phenotypes.
Yes, their lungs are failing in completely different ways. Now, if a healthcare system groups both patient A and patient B under one broad early COPD umbrella, just to satisfy a unified consensus guideline, they are likely to receive the exact same generalized clinical intervention.
Based on the unified standard.
Right. The doctor follows the guideline. But patient A might desperately need a therapy targeting tissue destruction, while patient B might need an intervention focused entirely on reducing airway inflammation. By unifying the definition to make the rulebook easier to write, we risk prescribing interventions that completely fail to halt their specific trajectories.
I see.
You might give patient B the lung equivalent of a raincoat when they actually need sunscreen. The granular complexity you want to engineer away is the very roadmap required to save their lung function.
I hear that. It is a vivid picture. But the counter-reality is that without a consensus definition, patient A and patient B might not be identified at all outside of a highly specialized million-dollar academic cohort study.
Oh, I wouldn't go that far.
It is true, though. A standard primary care clinic simply does not have the resources, the time, or the specialist training to parse through 5 different conflicting diagnostic frameworks just to catch a disease early. My stance remains firmly rooted in the systematic review's primary conclusion. Scientific progress in halting COPD requires the rigorous standardization of definitions.
Even at the cost of precision?
It is the only way to validate precision on a global scale. We need that unified baseline to allow for the massive international validation of disease predictors. If we ever want to move early intervention out of the ivory tower of academic studies and into everyday clinical practice where it actually helps millions of people, we have to speak a single diagnostic language.
But we lose the nuance.
The plurality of terms, PRISM, Gold Zero, pre-COPD, while physiologically fascinating to researchers, creates a massive barrier to the large-scale, definitive trials required to prove that early intervention actually changes a patient's life.
And my position remains that the rich heterogeneity of the current terms is absolutely vital for accurate early stratification. The complex predictive models highlighted in the Watson Review, from advanced CT scanning to machine learning, represent the true future of pulmonology.
They are the future, yes.
And they require the exact plurality of data that a singular consensus definition would erase. If we reduce the complex climate of the human lung to a single, easily digestible metric, we will inevitably fail the individual patients who do not fit perfectly into that artificial box. The semantic debate we are seeing in the literature reflects a biological reality, and we should embrace that complexity, fund the tools to understand it rather than try to write it out of existence for convenience.
I think where we absolutely converge today, and where the Watson et al. Material is incredibly clear, is the profound, urgent importance of the timeline.
Yes, 100%.
Regardless of whether we call it PRISM, Gold Zero, or early COPD, identifying patients early in their disease trajectory prior to the traditional diagnosis of irreversible airflow obstruction is paramount. The window to actually modify or halt the progression of COPD exists. We both see that window, and we are both advocating for the best way to leverage it before it closes on the patient.
I completely agree. The ultimate goal of halting disease progression is the shared North Star here. And I think we also both agree with the review's assertion that the current predictors identified in these cohort studies, whether they are self-reported clinical symptoms, detailed spirometry measures, or structural CT metrics, require rigorous, large-scale validation.
Absolutely.
We may vehemently disagree on the terminology required to structure that validation, but the necessity of doing the work is undeniable.
It really reflects the inherent tension in all of modern medical research right now. We are constantly caught in this intense tug-of-war. On one side, the vital need to standardize data for broad, practical, global clinical application. On the other side, the absolute imperative to preserve granular complexity for the sake of individualized precision medicine.
It is a delicate balance.
The Watson Review perfectly encapsulates this struggle, and realistically, it opens the door for further exploration into how emerging tools like artificial intelligence might eventually reconcile this gap. Perhaps one day soon, an AI can analyze the deeply nuanced, complex variables of PRISM and GOLD Zero, and output a clear, actionable clinical directive for that primary care doctor.
Exactly. We leave the listener today to weigh the merits of that consensus versus complexity. The systematic review's data brilliantly supports both the desperate need for clinical clarity and the undeniable, messy reality of physiological variation.
And so we find ourselves stepping right back into that diagnostic landscape we discussed at the beginning. We might desperately want the clean, simple alert of a weather siren or a jagged white line on an X-ray to point to, but the beginning of chronic lung disease simply refuses to be that simple. The waters remain muddy, but as the Watson Review shows, we are finally building the right tools to navigate them.
We just have to decide which map to use.
Thank you for joining us on The Debate.
Thank you so much for watching today's session on medical English and professional development. We hope these insights help you bridge the gap between B2 and C1 in your career. If you found this video helpful and want to see more content like this, please make sure to give it a thumbs up and hit the subscribe button. Your support helps us grow and continue providing high-quality resources for your learning journey. Don't forget to click the notification bell so you never miss an update. See you in the next video.